Good evening, sir. We are of Group 7 and we have done our project on reinforcement learning based multi agent portfolio management system for improved investment decision making. Myself, I am Abhinay. Mourya and Bhuvana Chandra are other group mates. And coming to the overview of our project, the portfolio management system using reinforcement learning with the A to C, PPO, and DDPG model parameters is designed to optimize investment decisions based on the historical data from the Yahoo Finance dataset. The system employs three popular reinforcement learning algorithms that learn and optimize investment strategies by continuously adjusting the portfolio composition. The system is evaluated on a range of assets in the Yahoo Finance dataset and achieves superior results compared to the traditional portfolio management strategies. The system is flexible and can be adapted to the different investment goals and risk preferences. Overall, this portfolio management system provides a promising framework for optimizing investment decisions in an uncertain financial market using reinforcement learning techniques. And our main agenda is here first we'll collect the data and we'll perform sentiment analysis. Then by using modeling agents, we'll simulate trading in the environment and then we'll perform back testing. Then we'll perform the evaluation. And coming to the introduction, the portfolio management involves selecting and managing a group of assets to maximize returns and minimize the risk. Traditional portfolio management strategies based on statistical models often fall short in capturing the full range of market dynamics and optimizing returns. The reinforcement learning RL is a promising approach to portfolio management system that involves learning and optimizing investment strategies through trial and error methods. The system was evaluated using the Yahoo Finance datasets and compared with traditional portfolio management strategies. The RL algorithms such as A2C, PPO, and DDPG learn from the historical data to make decisions that maximize long term rewards considering the uncertainty and volatility of the financial market. The proposed portfolio management system utilizes A2C, PPO, and DDPG RL algorithms. The system can be customized to accommodate different investment goals and risk preferences. And the portfolio management using RL provides a promising framework and optimizing investment decision in an uncertain financial market. So, by learning these from historical data and adapting to the market conditions, the system can help investors to perform decisions and achieve superior investment performance. And coming to the aim and objective, the objective of this project is to create and execute a portfolio management system that employs reinforcement learning methods and incorporates multiple agents to enhance investment decision making. The system will be assessed based on its capacity to generate profitable portfolios and surpass conventional portfolios management approaches. And coming to literature review, in the year 2008, some of authors reviewed that reinforcement learning has gained attention in portfolio management for its potential to surpass traditional strategies. One of the author compared that DDPG, PPO, and PG algorithms, and by comparing these algorithms, they found that PG performed the best. And another author in 2019 proposed a hybrid DDPG and PPO framework for portfolio management by achieving superior performance in Chinese stock market. And the RL algorithm shows promise but require further research for the optimal parameter settings and feature selection in the different financial markets and investment strategies. And now my friend Mourya will continue.
Hello, this is Kona Chandra, and now I'm going to discuss about the paper written by Fazan Soleimani in the year 2019. The paper proposes a novel approach to the portfolio management based on the deep breath framework, which uses deep reinforcement learning and restricted stacked autoencoder to optimize investment decisions. It is used to demonstrate the effectiveness of their approach in mitigating the market risk and improving investment returns using the real world datasets. One key contribution of these paper is the use of the dimensionality direction and the feature selection with the restricted stacked autoencoder to select only the most informative abstract feature for training and convolution neural network. The author also introduces an online learning strategy to handle concept drift and blockchain solution to mitigate the settlement risk. The result of these experiments demonstrate the potential of approaches in outperforming current investments strategies while minimizing market risk. However, further validation of these proposed approaches on the datasets and market is necessary to establish its generalizability. Coming to the next paper written by Mr. Alistair in the year 2020, the author of these research provided a brand new portfolio management approaches such as deep reinforcement learning using deep reinforcement learning. The claim that it is difficult for the conventional portfolio management techniques to adjust to quickly shifting market conditions. They did a review on the previous studies on reinforcement learning and portfolio management. They go over numerous portfolio optimization strategies such as mean variance optimization, risk uh, parity, and they examine earlier researches that the using reinforcement learning to manage portfolios. They suggested algorithm and it used and thoroughly explained by the authors such as deep q network. And coming to the test findings and demonstration of the deep based strategies beats alternative approaches in terms of risk adjustment returns and sharpen ratio. The study of shortcoming potential for further paths for the research in this field are discussed by the author in the conclusion. Coming to the research gap in this field of reinforcement learning for investment decisions, there exists a research gap in the application of the approaches to a real world financial markets. While there have been a numerous studies and simulations that have been demonstrated by the potential of the reinforcement learning for portfolio optimization, there is a limited evidence of effectiveness in real world investment scenarios. Uh, like including the considerability of the multiple assets and the risk management strategies, the lack of evidences and the limited scope of existing studies present a significant opportunity for the further research in this area. Coming to the proposed architecture, the step involved installation all the necessary packages and dependencies required for the running the portfolio management system. These packages include reinforcement learning libraries such as NumPy, Pandas, and YFinance, accessing financial data, defining the constraints. This step involves defining the constraints that will be used throughout the portfolio management system. The constraints include the start data and the end data of the time period for which the data will be downloaded and analyzed. It also includes a list of stocks from the S&P index, which are used in the creation of portfolio. The start date and end date, these constraints are used to define the time period for which the financial data can be analyzed. As we can see on the display, it is essential to set a start and an end date for the financial data to ensure that the portfolio is based on the specific time period. The S&P 500 is a market index that tracks the performance of the 500 large companies listed on the stock. Downloading the data using Yahoo Finance. This step involves downloading the financial data using the Yahoo Finance API. The financial data includes the historical stock prices, which will be used to calculate the volatility of this given stocks.
Yeah, there are basically three models which we have implemented. First is A2C model. So now let's get into the details. So the ATC model is a policy gradient method for portfolio management that combines actor critic and advantage functions. So the key parameters include the learning rate, discount factor, and value function coefficient and entropy coefficient. The learning rate controls the update of the neural network weights during the training. So with the higher rates leading to the faster convergence but possible overshooting. So the discount factor determines the focus on the immediate versus long-term rewards with the higher factor favored for the long-term returns. So the value function coefficient determines the emphasis on the value versus policy function. So with the higher value promoting the stability, so the entropy coefficient balances the exploration and the exploitation during the training, with the moderate values best for the portfolio management. So the A to C model, N steps and batch size parameters are important for the portfolio management. Using the reinforcement learning, increasing the N steps may lead to the more accurate return estimation, but also higher computational complexity. A higher batch size may result in more stable updates and faster convergence, but can also increase the memory requirements by optimizing these parameters and carefully tuning the A2C model. So it is possible to achieve the higher returns with the managing the risk effectively. So now let's get into the details of the next model, which is PPO model. So PPO model for portfolio management using the reinforcement learning has a key parameters that include the learning rate, discount factor, and GAE parameter. So entropy coefficient and the clipping parameter, value function coefficient, and number of episodes and batch size. The learning rate controls the size of the update step during the training and affects the convergence rate and optimizing the stability. So the discount factor determines the relative importance of the future rewards and is typically close to the one in the portfolio management. So the GAE parameter controls the trade-off between the bias and variance in the estimation of the value function. The entropy coefficient controls the degree of exploration and during the training and balance the exploration and exploitation to find the best investment strategy. The clipping parameter is used to restrict the magnitude of policy updates during the training and ensure stable convergence. So the value function coefficient determines the relative importance of the value function and the policy function of the PPO model. The number of episodes determine how many data is used for the update during the network training. So the batch size determines the number of samples used to update the weights of the neural network during the training. By carefully tuning these parameters, the PPO model can achieve higher returns with risk effectively in portfolio management. Now let's see the other model, which is DDPG model. The deep determined policy gradient model is a reinforcement learning model for the portfolio management. Like now let's see the parameters. So first is the actor learning rate, which controls the update step size for the actor network during the training. The critic learning rate controls the update step for the critic network during the learning, and discount factor determines the importance of the future rewards compared to the immediate rewards. Now let's see the target network. The DTPG uses two sets of networks which are local and target for the both actor and the critic. The target networks are updated slowly to stabilize the training process and noise process and encourages the exploration during the training using a random process which is controlled by the exploration factor. Now let's see what is a batch size, which it determines the number of samples used to update the neural network weights during the training and replay buffer used to store the experiences during the training and sample batches of the experiences randomly to reduce the variance. By tuning these parameters, DTPG can achieve the higher returns with effectively managing the risk in the portfolio management systems. So now let's see the experimental results, which is in the next slide. So yeah, the result of the portfolio management uses A2C PPO and DDPG model parameters, which shows the annual return of 0.17759 and cumulative return of 0.504. The annual volatility of 0.176 and the Sharp ratio of 1.0176, indicating that returns are higher than the risk-free rate. So the claimer ratio is 1.612706, including the favorable reward trade-off. The stability of the portfolio is 0.878 and the maximum breakdown is 0.1101. The omega ratio is 1.210 and the Sorio ratio is 1.49. However, the skewness and the curatives are not available. So overall, the sentimental analysis has added the accuracy, giving the model to predict the loss, and the high of the stock is the efficient and high returning way. The return way is calculated based on the initial value versus the final value for the prediction after prediction. So the MDT value is the measure of the largest percent loss versus the peak value of the portfolio to the lowest point, and the new peak is observed. So the measure requires tracking the historical values for the portfolio and over the given period of time. Therefore, cannot be calculated from just the summary statistics like sharp ratios. On the other hand, PF value of the model is calculated on the basis of formula, which is PF is equal to initial value plus return on portfolio plus cash flows in the cash flows out. So in the first table, it is a comparative of different agents with the different reward functions on national stock exchange parameters. So we can see what is the return which is produced by different agents, which are A2C, PPO, and DDPG. So the higher returns have been achieved through DDPG model. And in the second table, we can observe that the performance indicators of models with different reward functions on national stock exchange. So with the help of our proposed model, we are able to produce 37.8% return, which is the highest. Rest other models produce the lower returns.
Now we'll see about the main Python file. The code first imports the necessary libraries, including the portfolio environment and DDPG and PPO and A2C plot and torch multiprocessing. Yeah, it creates an instance of the portfolio environment and sets the state type to indicators. The repeating variable is set to I. And coming to the next step, it is created a function called main. The main function takes no input and returns nothing, but the main function initializes the plot and sets the start method for multiprocessing to span. It then loops for 50 rounds. In each round, the following steps are taken. The print function is used to print a message that starts of the round. Firstly, in the if statement is used to check if the plot in DDPG I2 testing.png does not exist. If it does not exist, the following steps are taken. As we can see that the DDPG agent is created and it is trained and it is tested. And if the statement is used to check if the file plots PPO I2 testing is done does not exist, it does not exist, the following steps are taken. The PPO agent is created and trained and tested, as we can see here. And now if the statement is used to check if the plot A to C I2 training does not exist, if it does not exist, the following steps are taken, which are the A to G agent is created, then trained and tested, and the main function is called. As we can see that when the main Python file is run, there are total of 49 iterations done. Now we'll discuss about the random agent Python file. Uh, the code first imports the necessary libraries, including the portfolio environment and the NumPy pandas in portfolio. Uh, then creates an instance of the portfolio environment and sets the type to the indicators. The next step is to create a list of store that stores for each iteration variable in the which initializes to the 0. A loop is then created that runs for the 50 iteration. In each iteration, the following steps are taken. The environment is reset. The wealth history is initialized to a list containing the initial wealth, and the done flag is set to false. The loop is created that runs until a done flag is set to true. In each case of the loop, the following steps are taken. The random action is chosen. The environment step will be chosen action. The observations is updated. The wealth is updated. The wealth history is appended with new wealth. The returns are calculated by taking the percentage change in the wealth history. The stats for the iteration are calculated using the Python folio library. The iteration variable is incremented. The next step is to calculate the annual return Sharp ratio and maximum brown ball. By running the Python random file through an iteration of 49, we get an annual return mean of 0.179 at the standard of 0.24 and Sharp ratio of mean 0.5815 with a standard of 0.58, as we can observe here. Now with the max drawdown of mean minus 0.39 with a standard of 0.085.
Here, first we'll import the required libraries and then we'll create the three lists that are A to C state, DDPG state, and PPO state, which will store the performance data for each algorithm. And each state list contains 50 data frames, which were created by reading the A to C and DDPG files respectively. and the index column equals to 0. Argument tells pandas to use the first column of the each CSV file as the index, and the next section of this script prints the performance data for each algorithm, and the print A to C statement prints the title of the section, and the A to C annual list contains the annual return for each of the 50 A to C experiments, and the np.mean and np.std returns the print of f annual return or an std np.std statement prints the mean and standard deviation of the annual return. The same process is repeated for the Sharpe ratio and the drawdown. And as we can see, the annual return for A to C equals to 0.1180, and the Sharpe ratio mean is equals to 0.66. For DDPG, the annual return mean is 0.19 and Sharpe ratio mean is 0.72. And for PPO, the annual return is 0.18 and the Sharpe ratio mean is 0.73. So here the final section of the script prints the performance of the DDPG and PPO.
So first, let's see the plot.py. So the code defines a set of functions for plotting data. The initialize function sets the axis of the plot to use the integer labels. The add underscore curve function plots a curve of different scores with the given label. The add underscore h line function plots a horizontal line at the given value with the given label. The save underscore plot function saves the plot to the given file name and given file title x label and y label. The legend is only shown if the legend argument is set to the true. So finally, the save underscore plot saves the figure to the file using the matplotlib save fig function. So now let's run the file and see. So after running the file, the graphs which are produced are saved to these files for the different agents. For A to C, these are the different graphs which are created, which are training, validation, and testing. For each and every model, like this only the graphs are created. Yeah, now let's see the baseline.py code file. So yeah, the code is more sophisticated example of how to use a portfolio environment to train the reinforcement learning agent to trade the stocks. The code first imports the necessary libraries including the portfolio environment, NumPy, Pandas and PyFolio and many more. Then it creates an instance of portfolio environment and sets the state type to indicators. The action shape is then obtained from the environment, and the intervals for training and testing sets are obtained from the environment. The by hold history of testing set is also obtained. The next step is to create a function called test. The function takes an environment weights and name as input and returns a list of the testing values. The testing function also first gets the intervals for the testing set from the environment. So it initializes the list to store the returns, and the environment is set the reset and the wealth history of the initialize to list the containing initial wealth. So the done flag is set to false. A loop is then created that runs until the flag is set to true. In each iteration of the loop, the following steps are taken. The environment is stopped with the chosen weights, the observation is updated, the wealth is updated, then the return is calculated and appended to the return history. So then the next step is to add the return history to the plot. The return is calculated by taking the percentage change in the wealth history. So the stats for the iteration are calculated using the PyFolio library, and the stats are written to the CSV file. So the next step is to read the tickers from the file, and the tickers are the used to create the pandas data frame. The data frame is used for getting the training and testing sets. The by hold strategy for testing set is then obtained. The by hold strategy is added to the plot. The efficient fortuner is then calculated. The weights of the maximum shape ratio and the minimum volatility are obtained, and the weights are used to test the environment. The results of the tests are then plotted. So now let's see the output. So after running the baseline.py, a file is created in the PPO. So This file contains a graph which has the training and testing data. So the graph is drawn to all these models, and for the different days from 0 to 480 days, and it gives the buy hold strategy and gives the volatility in the market. Now let's see the conclusion. In conclusion, the project aimed to develop portfolio management system using reinforcement learning and Yahoo Finance dataset. The process involves several steps, including calculating the technical indicators and developing the environmental constants and implementing a deep reinforcement learning. So the analyzing the results, the A2C, PPO, and DDPG models were used for the part of reinforcement learning algorithms, with each model having the specific parameters that were defined during the environmental design phase. The performance of the portfolio was evaluated using the metrics such as Sharpe ratio and back testing results and baseline statistics and comparison with the market index. Overall, the project demonstrates the potential of using deep reinforcement learning to optimize the portfolio and generate the significant returns by incorporating the historical data and technical indicators. The model can learn patterns in a stock market and more informed investment decisions. The use of different models and learning techniques further enhances the performance of the portfolio. The analysis of the results shows the portfolio generated during the significant returns and outperform the market index, indicating the effectiveness of the reinforcement learning approach. However, the project also has a limitation and areas for improvement. One limitation is the use of historical data, which may not affect the current market condition and may not be reliable in predicting the future stock prices. Additionally, the project could benefit more extensive data processing and feature engineering to extract more relevant features from the data. So the further research can be done to explore the use of more sophisticated reinforcement learning model and optimization techniques. In conclusion, the project showcases the potential of deep reinforcement learning in portfolio management and highlights the importance of data analysis and parameter tuning in achieving the optimal performance. As a result, the machine learning continues to evolve, and this is the growing opportunity to leverage these techniques in the finance and investment management to generate more significant returns and enhance the investment strategies. Thank you.